All right, we're going to start with the, I got to hand out that lesson. We're going to start with the two base curves, kind of like the learning goal. Do this again to make sure that everybody's on the same page. Sometimes it does take a few days, which we're on kind of day 3 now. We spent a day sort of exploring things and doing some work with technology. We did more stuff with technology yesterday, but we were supposed to, maybe not everybody did, but we were supposed to get to graphing by hand yesterday, and you definitely need to get to graphing by hand today if you haven't yet. Okay. And like I said, it can take a few days for things to come together. And what we're adding on a new dimension or a new element today of this, but it's not too tricky. The first one we do together, well, the first two are the base curves, then the first one we do together on the back of the page is straightforward. What you need to know, and I'm not sure that this is what people were doing, but I saw a few people looked like they might be still trying to use the calculator to graph. And this is a similar thing that happens in grade 10 and when we're doing parabolas. And what I always say is, if you're doing it with the table of values by punching in values into a calculator, stop what you're doing. Don't bother. Let's sit down together, go back to the drawing board and figure this out, because that is not what we want to be doing. The whole point of this is that we get to the stage where we know what the curve is like, and we understand what the values in the equation do to change that, and we can do it without our calculator. You might need your calculator to calculate the max or the min, I don't know, if they're nasty numbers. Starting tomorrow, you might need your calculator to work some stuff out. But up till now, we don't really need the calculator. We're not doing a table of values. We did that on the first day, but we're not doing that anymore. So try to keep that above all things in mind, that we're trying to do this just on our own. And we start, so we're going to start with y equals sine x. And we start with the 5 key points of sine that you just need to know. For those of you who weren't here yesterday, you might have been here the day before, but I know a few people feel behind. The idea is we start with the 5 points for sine that we just know where they are. And if you don't know where they are, then you just got to keep practicing until you get to a point where you do. And you can graph them easily. So sine, I am going to draw the 0 line. You don't have to, but some of you might find this useful. So I'm going to draw in the 0 line. And for the base curve, it's at 0. Okay, so it's y equals 0 for the base curve. And sine starts on the 0 line. And it starts at 0 for x as well. So let's put a big point right there. That's our first point for sine. Right at the origin. Cosine doesn't start there, but sine does. For the base curves, we count 3 squares. And for this grid, if I change the grid, it would be different, right? But this is the same grid we were using yesterday. So we count 3 squares to 90. The next point occurs at 90. And it is at the maximum, which is 1 for the base curve. Remember, these are all things that you just need to know. We're not punching into our calculator to figure it out. We want to get to a point where it's memorized. Sine starts on the 0 line, goes to the max, goes back to the 0 line, then goes to the minimum, and it's counting every 90 degrees, 90, 180, 270, and then back to the 0 line of 360. And you can already see it forming that sine curve, that wave that we're hopefully starting to get familiar with. We only have 5 points. The first day when we did the table of value, we had more points in between these because we didn't know what the curve looked like. We had to map it out a bit better. But now when we're getting used to this, we use these 5 points to define the graph. Just like with quadratics, there were 7 key points that you kind of used, right? There's other points on the curve. You memorize 7 of them, over 1, over 2, over 3. and then you transform it from there. So then we're going to connect this with a curve. Remember I said yesterday, try to make it curved, not straight. If it's hard at first, that's fine. You get better at it as you practice. And we're going to highlight some of the properties. Remember, the zero line is at 0 here. So from there up to the max, I traveled 1, which was 2 squares because 1 square is a half, but it was a value of 1. And from the 0 line down to the minimum, I went down 1. Together, that's a whole distance of 2, but remember the amplitude is half of the whole distance, so the amplitude is 1. There's 2 ways to think about the amplitude. It's the distance from the 0 line to the max and the 0 line to the min. It has to be the same. It's not the same, you've done something wrong. Or it's half the distance from the max to the min. It's always positive. Like we already said, our 0 line is y equals 0. The period of this graph is the length from the start to the finish. So that's from 0 to 360 is 360. Just watch for a minute. If I continued this curve, so sine starts on the 0 line and goes up to the max. If I've completed 1 cycle, I'm back on the 0 line and I'm traveling back up to the max, which would be there. Remember, these are periodic. We are starting to get used to only graphing 1 cycle, but these are periodic. They actually continue forever in both directions. So the period of 360 is also the distance from a maximum to a maximum. This will be 360 degrees. If you do 450 minus 90, you'll get 360. No matter which 2 points you pick, as long as there's 1 complete cycle between them, the distance will be the same. For the base curve, it's 360. We happen to be getting used to graphing 1 cycle, the first cycle that looks the same all the time. Any questions about that? And then, so this is my, this is my start. And today we're going to start playing around with where it starts. So sine starts at 0 this direction, but also 0 this direction on the 0 line. Right? So we think about where it starts in terms of vertically, but we also think of where it starts in terms of horizontally. Both of those things can change. And then the start plus the period will equal where it ends, which in this case is there. Just something to think about. Whatever my start is, which is 0, plus the period is 360, it ends at, in this case, 360, obviously, but that's the idea. These are the relationships that are involved. Okay, so, and again, we covered that yesterday, but this is something that's crucial. You have to know those 5 points. Once we know those 5 points, we look at the transformations and how they change those 5 points. Now we're going to do cosine. We'll be a little bit faster probably this time. I'm going to draw in my 0 line again. And the properties of sine and cosine are all the same. It's just where it starts vertically that's different. Where it starts in the cycle is what's different. So the 0 line for the base curve again is y equals 0. And remember yesterday, I'm sure a lot of you remember this, but yesterday, one of the key values moves that 0 line. You got to know that. And then you often we start with where the 0 line is when we graph these things. Okay, so cos x doesn't start on the 0 line like sine, it doesn't start there. It starts at the maximum value. But it's still, the base curve still starts at 0x, is where we think about it starting. I still count over 3, which on this grid, which is 90, and I go to the 0 line. 3 more to the minimum. 3 more back to the 0 line. 3 more up to the maximum. And then drawing the curve. All the properties are the same. From the 0 line up to the max is 1. From the 0 line down to the min is 1. So the amplitude is 1. The period is 360. But the start, it starts at 0, but it starts at the maximum, whereas sine starts at the 0 line. Any questions about that? On the back of your page. For some of you, this might be useful. The instructions are written out here in order that you would probably do them. So if you're stuck on anything, I would read through those instructions and see where you're at. We're going to start by writing out the amplitude. Yesterday we were starting about where we're writing A equals C equals D equals. So you could do that first too. That's a necessary step. If you're not able to figure out what A is, you're not going to be able to do anything else. So you might start with that. What are the values of A, C, and D? Once you've got that, you write out the amplitude and the 0 line, and then use those to think about where the max and the min are. And some of you might be writing this out. Some of you might be doing this in your head. Then we're going to think about those key 5 values. So for sine, you start on the 0 line and go to the max. For cosine, you start at the max and go to the 0 line. So just thinking about those key values. But then today, we're adding in a horizontal shift. So when you start thinking about where your first point is, you're going to have to think about, is it shifted horizontally as well? And then the other thing, that right now it's always 3 squares, but that's not always true for all graphs. So you're going to think about how many squares to the next point. And if it's 3 squares, then it's always 3 squares to the next point. If we change the scale and it's 4 squares to the next point, it's always 4 squares to the next point. So once you determine how many squares, then you're just counting and plotting points down. And it actually becomes kind of repetitive, kind of easy. All right, so let's get into this. For this graph, this one's like the ones we did yesterday. There's nothing tricky, nothing new or tricky about it. What's my A value? Thank you, -2. What's my C value? It's 0 because we haven't started doing that yet. And my D value? Somebody else? 1, very good. And what you need to know is, where do you get the amplitude from and where do you get the 0 line from? Because remember, that's what we're starting with. The amplitude is 2. It comes from the A value, but it doesn't include the sign. The amplitude is always positive. And the 0 line is 1. It comes from the D value. See, again, if you didn't know these things, you wouldn't be able to do this. These are the things that you need to just know. Put your pencil down and watch. Picture this. When I go back up here, the amplitude was 1. I started at the 0 line and went up 1 to the max and down 1 to the min. That's what the amplitude means. So if I'm doing this for a new graph, my max starts at the 0 line, which in this case is 1, and goes up the amplitude. From the 0 line up 2 in this case, because the amplitude is different. So my max is going to be 3. Start at the 0 line and go down the amplitude. See, if you write it out, if you can get in the habit of writing out these steps, when you go to graph, it's like trivial. Because you're like, zero line, max, zero line, min, zero line. You already know where all those points are. Super easy. And there's no horizontal shift, so we don't have to worry about where we start, and we're not changing any of the scale, so we don't have to worry about squares. It's 3 squares. You could write that down if you want. 3 squares to next point. And it starts at 0. Okay, let's try to draw this. I'm going to put in my 0 line. Again, you don't have to draw it in, but I would imagine some people find it useful. This is sine. Oh, there's one last thing we have to think about that I haven't mentioned yet. What is it? The negative sign. What does that do to the graph? Kristen? Flips it. Reflection in the x-axis. I'm going to write that down for a mental note kind of thing. Reflection in x-axis. So, it's sine. We start on the 0 line. No shift, so I'm starting at x equals 0. The flip means instead of going up to the max, I'm going down to the minimum. We already have the minimum set up. It's -1. I know I'm counting 3 squares. I go down to the minimum. And remember, that is the value of the amplitude. It's 4 squares, but every square is a half, so it's 2. 3 more squares, sine goes back to the 0 line. 3 more squares, sine goes up to the maximum. The maximum is 3. 3 more squares back to the 0 line. Yeah.
In the first, or in the coast graphic, you started at 1 and 0 was at 0.
Yep.
So how do you determine where we start the first?
This one starts at the maximum. That's what I would memorize about cosine. So I think we're going to do a cosine example next. So we'll try that one and we'll see. But cosine starts at the max. If it was reflected, I'd be starting at the minimum. I go from the max to the 0 line to the min to the 0 line to the max for cosine every single time. And cosine looks like sine if you extend it, right? So once you know one of them, you kind of know both. If you just remember that when I compare this to sine, cosine just starts there. 0 line, minimum, 0 line, maximum. Does that answer your question? All right, let's try the next one. What's my A value? Is the A value changed? No change, so it's 1. What's my D value? Is the D value changed? There's no change, so it's 0. In other words, it's staying the same as the base graph. What's different here is my C value. And the C value always has the opposite sign from inside the brackets. So my C value is 60 degrees. So my amplitude is 1. My 0 line is y equals 0. My max is 0 plus 1, which is 1. You don't have to write that out every time, 0 plus 1. You can just say max equals 1. min equals 0 minus 1, which is negative 1. But where's my start? Yes, it's going to be because it's cosine good. Where's my start horizontally? This is the first time we're seeing this. I'm just going to write this down. This is a shift right 60. Right? It's negative inside the brackets, but that means it has the opposite effect. So it's a shift right 60. So my start is at 60. So it's cosine, which starts at the max, but I'm shifting right 60. My zero line is 0. Okay, take a look. Watch if you want. It's cosine. Amplitude is not changed. Zero line's not changed. So I start at the max, which is 1, but I go over 60. So these are counting by 30s because it goes 30, 60, 90. So the second line here is 60. So I go to 60 and I put my point for cosine at the maximum. Then I count 3 squares and I just know that cosine goes to the 0 line. 3 squares, cosine goes to the minimum. 3 squares back to the 0 line. 3 squares back to the maximum. My period is still 360. I just took the whole thing and shifted it over. Any questions about that one? Yeah.
Sorry, okay, why are you counting 3 squares?
Because again, that's just the base graph. That's what sine does. When we graphed it a couple of days ago and we just punched values into the calculator, we noticed that sine and cosine, like, I'll go back up to sine, okay? Let me go back up to the top here. That when I put in sine of 90, I get 1. When I put in sine of 180, I get 0. That's what sine does on our calculator. It's just that's the way it works. Okay, there's a really good reason why it works, but it would take a lot of days for us to explore that. So we're not going to worry too much about that right now. But that's what happens. Again, we're kind of memorizing that. Okay, and there is something that we're going to explore where I can change that. And instead of happening at 90, it could happen at 120. And that makes things a lot trickier, but we're not doing that yet. So the base graph is every 90.
And is that only like when it's like 60, like, because you started at 60 and kind of
Yeah. So it's still the same even if I shift. But the thing that's important to recognize is I've drawn up these grids and I made it so that 3 squares goes to 90. So it's not always every 3 squares, it's always every 90. If 1 square was 10, I would need 9 squares to get to 90, right? Which would be harder to graph. But we'll practice that when we get there. So in this case, 3 squares is 90. All right, let's try one more. You can go ahead and try. I think some of you are already doing that, but you can go ahead and try this one on your own if you like. there's my little solving structure. All these blanks that if I can fill them all in, I basically have all the properties I need to solve. If you're looking for a step-by-step process to graph these to understand this, that's it right there. Remember those steps. So that's what I got when I fill them in. The amplitude is 4. It comes from that 4 out front. C is negative 90. Remember, it has the opposite sign, so that's a shift to the left, 90. And D is 0 because it's plus nothing. Plus 0, there isn't anything written there. So my amplitude is 4. My 0 line is y equals 0. And my start is negative 90. It's sine. There's no reflection. Where does sine start? Starts on the 0 line. The 0 line is y equals 0. But so it would normally be here. But I'm shifting it to the right 90. Or sorry, to the left 90. To negative 90. Then 0 line, I forgot to do the max and the min. 0 line then so the max is 4, 0 plus 4, and the min is negative 4, 0 minus 4. So from there, I'm counting 3 squares, 1, 2, 3, and I'm going to the max, which is 4, which is at the very top of this grid. 3 more squares back to the 0 line. 3 more squares down to the minimum. 3 more squares back to the 0 line. And there you go. There's one cycle of that graph. It still looks like sine. It looks taller. It still looks like sine. So I've got some paper practice. If you haven't yet, you absolutely 100% have to start doing these on paper because we need to be able to do them by hand. But you can also try a few. We've only got 20 minutes. You can do this in your MSIP. You can do this now. I still have a few iPads here. And what you want to do by now, though, I think, is not just be doing sine. Click to do both. And turn on phase shift. So that when I make a new graph, it might, sometimes it doesn't because it's random, but it'll add in a phase shift. So again, watch this. If I place wait, I want to move the grid first because I'm going back 150. So I place a point. Oh, this is a tricky one. It's cosine, which starts at the maximum. So I go back 150, which is going to be here. But I have to go down 1.5 and then up to the maximum. And again, as you're doing this, if you start to get lost and you're not sure, I can click this to turn on the points and look at that. I got that point correct. But don't cheat too much. If you turn the points on or turn the line on too much and you cheat, you're not going to be learning anything. From there, I would go over 3 and to the 0 line, which is at 1.5. Whoops. Then over 3 down to the minimum, which from there is down 2. over 1, 2, 3, back to the 0 line, over 1, 2, 3, back up to that maximum. And again, I can check and make sure that my curve goes through. So I changed it a little bit so you just see one curve stands out nicely, but you can see how it does continue back and forth. So you can try that too.